The periodic table is a chart created by Mendeleev. It organizes the elements into groups and families by their physical and chemical characteristics. Did I do it? Oh. The elements are placed on the periodic table according to their atomic mass. They are placed so the atomic mass increases from left to right.
The periodic table consists of 8 main groups, 1A through 8A. The groups represent the number of valence electrons for each element. Group 1A has 1 valence electron, Group 2A has 2, and Group 3A has 3, and so on. All elements are in one of 3 groups: metals, nonmetals, or metalloid. There are 91 metal elements, 19 nonmetal elements, and 7 metalloid elements.
The elements are also put into families. There are 9 different families. There are alkali metals, alkali earth metals, transition metals, boron group, carbon group, nitrogen group, oxygen group, halogens, and noble gases.
Alkali metals are softer than most other metals and are the most reactive. The metals in the alkali family are lithium, sodium, potassium, rubidium, cesium, and francium, also known as group 1. These metals are so reactive with water and oxygen that they do not naturally occur in their element forms and mostly are stored under oil to prevent contact with oxygen and water. Alkaline earth metals make up group 2 of the periodic table. These elements combine readily with other elements and are not found as free elements in nature. These elements are beryllium, magnesium, calcium, strontium, barium, and radium. Some of these elements and compounds are used to color fireworks. A red firework is a compound of strontium and lithium. Transition elements make up groups 3 through 12. They are called transition elements because they are considered to be in transition between the main group elements. The transition metals each have unique qualities to them. The elements in this family are iron, cobalt, nickel, copper, silver, gold, zinc, cadmium, mercury, the lanthanides, and the actinides. The carbon family makes up group 4A. Much of the similarities between the elements are that they all have 4 valence electrons. Carbon is a nonmetal, silicon and germanium are metalloids, and tin and lead are metals. The elements in the boron group are boron, aluminum, gallium, indium, and thallium. Boron is used to make heat-resistant glass. Aluminum is the most abundant in Earth's crust. Gallium is used in electronic components, and the last 2 are rare metals. The nitrogen family makes up group 5A. These elements tend to share electrons and form covalent compounds with other nonmetal elements. The first elements in this group, nitrogen and phosphorus, are used to make fertilizers. The next 2 elements, antimony and bismuth, are used for fire sprinklers because they lower other metals' melting point. Arsenic was once used as a pigment in paints, but is no longer because many arsenic compounds are toxic. Group 6A contains the elements in the oxygen family. These elements are oxygen, sulfur, selenium, tellurium, and polonium. Oxygen is the most important element for human life. Sulfur combines with metals to form sulfides of distinctive colors used in paints. Selenium is the most common of the last 3 elements. It is found in multivitamins but can be toxic if you get too much in your system. Fluorine, chlorine, bromine, iodine, and acetine are called halogens and make up group 7A. They are very reactive in their elemental forms, and their compound forms have many uses. Halogen light bulbs contain small amounts of bromine and iodine vapor. Fluorine is used in toothpaste to prevent tooth decay. Chlorine compounds are used to disinfect swimming pools, and scientists use bromine to stain DNA samples. Noble gases exist as isolated atoms. They are stable because they have 8 valence electrons, making a complete shell. The elements of noble gases are helium, neon, argon, krypton, xenon, and radon. Noble gases are odorless and colorless, but with an electric current, these gases will emit colors such as in signs. The first line shows the name of the element, in this case bromine. The second line shows the element's number of protons. The next line is the element symbol. Bromine's symbol is Br. The final line is the element's atomic mass, which also tells you where it is placed on the table.
Maliya, you can't be right there.
Why?
Because it's...
No, you don't. You look fabulous. Read it. I'm a horse. The elements are placed on the periodic table according to their atomic mass. They are placed so the atomic mass increases from left to right.